of chili experts has discovered a new kind of spice for cooking that they claim has a mean spiciness of 200 Scoville heat units with a standard deviation of 0.5 SHU. Test hypothesis mean is equal to 200 SHU against the alternative hypothesis of a mean not equal to 200 if a random sample of 30 chilies is tested and found to have a mean spiciness of 195.25 SHU. Use a 0.01 level of
1. We have to find the null and alternative hypothesis. In our problem, the mean is equal to 200 and alternative hypothesis, the mean is not equal to 200. For step 2, we have to determine the level of significance, which is 0.01. Our HA is non-directional. Hypothesis test is two-tailed since it is non-directional, and the appropriate test statistic is a z-test since n is equal to 30. For step 3, we have to find our critical region. In this particular problem, we have to use the critical value of a z-table and the level of significance, which is 0.01. You have to locate it in the z-table, which will give you the answer of 2.576. For step 4, we have to compute for the value of z. Use the given data in your problem. We have a sample mean of 200, a mean population of 195.25, a standard deviation of 0.5, and a random sample of 30. Use the equation z equals sample mean minus mean of population over standard deviation divided by the square root of random sample. Substitute the given data and then solve for it to get the answer of 3.06 as your z. For problem number 1, in step 5, we have to determine whether to accept or reject our HO. First, in order to do this, we use the critical region in step 3, which is 2.576, and step 4 z value of 3.06. Then, create a curve. As you can see, our curve has two shaded tails since our hypothesis test is two-tailed. Now, we can say that our HO is rejected since the z value 3.06 is in the critical region, which brings us to our conclusion in step 6 that the average spiciness is not equal to 200 but is greater than 200.
The principal is trying to encourage students to stop driving to campus. The university claims that on average, it takes at least 20 minutes to find a parking space on campus. The principal has a sample of the last 5 minutes he drove to campus and calculated a population mean equal to 20. Assuming that the time it takes to find a parking space is normal with a standard deviation of 6 minutes, perform a test hypothesis with a level of significance of A equals to 0.10 to see if his claim is correct.
In problem number 2, for step 1, we have a null hypothesis of a mean equal to 20 and an alternative hypothesis of a mean lesser than 20. In our step 2, the level of significance to be used is 0.10. Our HA is directional, our hypothesis test is one-tailed, and our test statistic is a t-test because n is lesser than 30. For step 3, we have to locate for the critical region. To do this, we have to answer the degree of freedom, which is a formula of n minus 1. Substitute n by 5 since 5 is a random sample, subtract it by 1 to get the answer of 4, and then use a level of significance of 0.10. Use this equation and then substitute all of the values, A with 0.10 and a DF with 4. Locate the values in a t-table since it is a t-test to get the answer of 1.533. And then use a negative sign because the mean is lesser than 20. Step 4. To compute for the t-value, use the given data in the problem and then use the formula, substitute the values to get the answer of negative 2.98. In step 5, use the critical region in step 3, which is negative 1.533, and step 4's t-value of negative 2.98. To create a curve which has one shaded part in the left side, and the t-value is located in the critical region, which means that our HO is rejected since it is in the critical region. Which brings us to our step 6, that the average time to find a parking spot is less than 20 minutes.
Problem number 3. A teacher wishes to study the amount of time students in her major subject spend studying. she believes that the average time should be 70 minutes. So in order to know, she asked her students to report to her the time they spent in studying. A total of 10 students responded. The average time spent is 73 minutes with a standard deviation of 8.5 minutes. Test the hypothesis that the mean is greater than 70 minutes using a 0.05 level of significance.
For step 1, our null hypothesis is a mean equal to 70. Our alternative hypothesis is a mean greater than 70. In step 2, our level of significance is 0.05. Our HA is directional, hypothesis test is one-tailed, and the test statistic is a t-test since our n is lesser than 3. In step 3, to find the critical region, we have an A of 0.05. Solve for the degree of freedom, which has a formula of n minus 1. Substitute n with 10 since 10 is a random sample, minus 1 to get the answer of 9. Use the equation P greater than P sub A, comma, degree of freedom. Substitute A with 0.05 and BF with 9. Locate the values in the t-table since it is a t-test to get the answer of 1.83. In step 4, to compute for the t-value, we have to use our problem's given data. Use the formula and substitute what's in the data to the formula to get the answer of t equals 1.12. In step 5, we have to use our step 3's critical region of 1.833 and our step 4's t-value of 1.12. Create a curve that is one-sided, which is shaded in the right side because our HA is greater than our random sample, and accept our HO since our t-value is not within the critical region, which brings us to our conclusion in step 6 that the average time spent is greater than 70 minutes.
You give me the peanut butter to my chest.